Do you know how the DC from the internal battery of the outdoor power supply is converted into the 110 volts or 220 volts AC power that we often use? Today, let's talk about the working principle of the inverter. The power supply of the battery is a DC circuit, and the current flow direction is as follows, with 4 switches. When the blue switch closes and the red switch opens, the path of the current flowing through the load is as follows. Conversely, when the red switch closes and the blue switch opens, the current path will also be reversed. And based on this direct current path, we will obtain a square waveform, which is square wave alternating current. Of course, the frequency of the AC power is 50 Hz, and the switching circuit continuously switches 50 times per second, which ordinary switches cannot achieve. Therefore, we need to use the chip to control the IGBT transistor switch to achieve this, which can even reach tens of thousands times per second. We call it oscillation circuit. Square wave alternating current has drawbacks such as light bulb. If it's an electric fan, it can easily cause loud noise. Therefore, if the inverter supplies power to position instruments, power or musical instruments, it needs to be out with smooth sine wave AC power. Here we need to use PWM pulse width debugging technology. Simply put, the larger the amplitude of the sine wave, the longer the switch closure time. The smaller the amplitude, the shorter the closing time. And this way we will obtain this graph, which will eventually become the 110 volts or 220 volts AC power we use after being boosted by transformer. To make the curve smoother, we need to add capacitors and inductors to the circuit for filtering so that we can obtain a pure sine wave. Of this kind of inverter, let's take a look at the points to pay attention to when choosing an outdoor power inverter. Firstly, the load power. To ensure that the load can operate for a long time under high load conditions, an inverter with the power 1.2 times or more of electric equipment can be selected. For example, if a 3000 volts load is matched with 3000 volts multiplied 1.2 inverter, we have a rated power of 3500 volts. Secondly, from the perspective of the battery. In order to ensure that the battery continues to supply power to the inverter without any problems, the continuous current capacity of the battery must meet the long-term load-fault operation of the inverter. Thirdly, the lithium battery BMS. As an energy transfer station, the inverter has input power and output power. The input power is provided by the lithium battery, so the continuous current capacity of the BMS should be considered. According to the formula for selecting the BMS, the continuous current value of the BMS is like this. Remember that it must be the input power of the inverter, not the output power marked on the inverter. Finally, when selecting an inverter, we must pay attention to whether there is a false power mark and ensure that the marked power is the rated power, not the instantaneous maximum power. And it can work continuously for more than 5 hours under high power conditions, which is the reliable quality. Alright, this is the end of today. If you think our video is helpful, like and subs appreciated. See you next time. Bye.